Escape Engineers Inspector Summary Video. Here we are in New York, the consulate here, and what we have is a fire escape that is tied into this additional fire escape system all the way to the ground, probably about 6 to 8 stories. That what we have here is an existing fire escape that did not pass the confidence test, so we cannot proceed to a load test, and we cannot proceed to a certification in that it doesn't pass. Fire escapes of this size and this age usually have had all these bolts switched out in the 25 to 50 year life cycle of this, and we're already at probably 50 to 75 years old. So all original hardware, no evidence of maintenance, a lot of welded connections. So what we have to do in order to work on this fire escape is refurbish the fire escape, spot repair it, and then load test, proceed to a load test, which is thousands of pounds of weight both on the treads and the platforms of this fire escape. Or we can, to avoid the load test, you can basically refurbish the entire bolted connection structure that should have been done in the 25 to 50th birthday of this fire escape. So every one of these, if they get swapped out, there is no load test. Otherwise, I can spot repair some of these that need to be done that have visible rust in the connection, but then we must proceed to a load test. This platform here is 5x4, there's 20 square feet, 2,000 pounds must be loaded on this fire escape. That's 2x4, 800 pounds of sand or water must be load tested on there for 30 minutes. Or these treads, probably 1,000 pounds need to be load tested on these treads. So again, 100% of the treads are full of rust, so 100% of the treads minimally got to get rebolted. As I walk down, I'm going to show all the connections that need rebolting. So 100% of these treads need to be rebolted. All the welded connections need to be x-rayed or load tested, or to avoid the load test, as soon as you put in bolts through here, you don't have to verify this connection. If the weld is bad, you still have to clean it, but you put in some bolts, no need to load test because you've certified it. Silicone shut everything to make sure the welds don't keep getting deteriorated. Put a bolt here, create a mechanical fastener connection here so that we can avoid having to verify a lot of these welded connections. But for sure, 100% of all the treads need to be done. The fire escape does need now to have a permit. You just can't work on this. So you need an engineer of oversight declared who is going to oversee the repair by a vendor. So a permit is required, engineer oversight is required. We do have lead on this fire escape, so you do have to have an EPA renovator's license on this fire escape to touch anything related to the lead on the paint, and you also need to meet OSHA requirements. This is a commercial building. You got to make sure that the OSHA requirements for lead are met. So with that being said, let's continue on down. We do have some evidence here and there of some changes of bolts, but not enough. I mean, a couple. I'm seeing less than 5%, a bolt here and a bolt there, but on average, in 25 to 50 years, which this fire escape is, we would have seen the bolts all changed out. All the mechanical fasteners would have been changed out. So major structural is where the posts are, minor structural is where the bars are. So the bars don't have to be rebolted, but they have to be verified. But every single connection, every joint needs to either be load tested, or you change out all the bolts and you get a certification. So all these rivets got to go, these bolts got to go, whether the connection is in good or bad condition. That's a certification. So spot repair and load test, full repair and load test. But 100% of all the treads are full of rust all the way down. So minimally, all the treads got to be changed on this. Not changed, but the bolts got to be changed out. 100% of the treads got to come out, and then the treads got to go back in, wire brushed and painted. And then you have to make sure you silicone shut the connections. All the stringer connections at the very top, if they're clean, silicone shut, load test, or change the bolts out, no load test. Any rust in the connections, you got to change the bolts out. 100% of all the treads. The superstructure up here, you see evidence of rust in some of the connections, so that means you got to change out the bolts. The bolts are showing wear on the nuts, all the nuts, so that means either the head of the nut is bad, you got to change the whole bolt out, make sure there's no rust in any connection. Up against the building, we got a lot of deterioration back here. You got to seal this up so water doesn't get back in there and creates ice jacking and rust jacking, which is pulling these things out from the building. And you see some evidence of that here. So that's all got to be sealed up, reconnected back into this parapet wall. You see evidence of rust jacking and ice jacking on the back of this. So 100% of the superstructure must be rebolted to avoid having to go to a load test. So that means that on that structure right there, if 50% of the bolts are bad, they got to be cleaned and rebolted. The remaining 50% now need to be load tested as a complete structure in order to meet the requirement. Otherwise, you refurbish that 100% of all its mechanical fasteners, seal all the joints, no load test required. and the fire escape is certified. Full paint job needed. You do have lead. 100% of all these treads are bad. And again, this is a good close-up of the connections, in that we got rust in the joints, but we got to change out the bolts. You see the rust jacking, ice jacking build. Those rusty tears are an indicator that water's getting behind there. Rust jacking happening there, as you can see, causing severe damage both to the wall and to the structure. So these things all need to be addressed. Again, with engineer oversight, a permit must be pulled. We've got some rust building up on the rail, and it's jacking the rail, twisting the rail in different parts. But again, all the major structural, you got to clean out all the rust. Any rails, all these rails, they've got little welds at the very top. Those need to be bolted so that there's a mechanical fastener, because if you just got a weld, I got to verify the weld at the top. I also got to verify, I got to make a connection here, because should this give way in any way, the welds snap anyway, somebody's going to fall many feet. 100% of all these treads need to go. We've got some damage to the bars. I don't know from what, but they need to be straightened out. We've got rust building up on that. You see that it bulges, so all that rust got to be cleaned out, put back. We got deterioration of some of the nuts, thereby forcing the connections to be changed. This is a connection problem, see? Just welded. As soon as I bolt that, I don't have to rely on that weld anymore. Nobody's gonna fall over. So 100% of any welded connection must be x-rayed and load tested, or if you mechanically fasten it and fix it, there's no need for a load test. So coming back down, as you can see, standard platforms, a lot of these rusty tears is an indication that water's building up behind a lot of these connections, rusting them out into the building. Now, all these connections into the building must be verified. As you can see, a lot of the interior is finished. So a lot of times, the only way that we're going to be able to verify the connections back into this building is to put a new epoxy bolt 6 inches away into the building, or we can put legs to the ground on all these major structural corners to avoid the need to verify into the building the 8 to 12 inches deep of whether or not that's that cavity and that C channel is in good order. So you must verify all these connections into the building, or nullify them by duplicating the connections. So there's a good example right there. That's a huge bulge of cement. We still have to find out just how much cement, how much the steel is in there, and how bad it is. If it's in bad order, we basically can encapsulate the area and create a new connection point 6 inches away, or we must deal with that connection and rebuild it, or take that piece out and put in a brand new one. We've got some steel that's coming down here, but if you look up there, there's a bulge full of cement. I mean, full of rust expansion. So angles have been added in the past to either reinforce. As you can see, all original hardware underneath of all these treads. Okay? So this is an indication that we've got rust. You got joint failure. All original hardware. We got some rivets. A lot of times when you got rivets, this fire escape is older than 75 years old. Rivets first and bolts came next. So this fire escape might be 75 to 100 years old. But again, all original hardware is still here on the fire escape. 100% of these treads needs to be changed out. Let me show you the gussets. These gussets that hold the stringer, some of them are full of rust. Some of them, the nuts are already eaten out. A lot of them, the treads, 100% of these treads are full of rust. They've got lead on them also. So one of the things you may want to do while you're dealing with the treads at this time is get them out of here and put in new galvanized treads. Major rust, huge amount of rust built up. But there's an emergency in this building. It's down on the 1st and 2nd floor. You have some connection problems here. Rusty tears indicating that there's a lot of ice jacking, rust jacking, and building up behind this. So to stop damaging the interior of this building, you got to stop and find out what's causing the water to get inside these. And as you can see, there's some repair work has been done in the past, but it wasn't complete, and water and rust is getting behind. So 100% of all these connections need to be spot repaired to proceed to a load test, or full refurbishment. There is no load test. 100% of all these treads need to be done. I would recommend some additional lines on this railing so that we can stop people from falling through. I doubt there's going to be any children here, but just should anybody trip, fall, pass out, they could fall through and pass down into these stairwells. As you can see, rust is building up. As you get lower and lower, you got more rust building up in all the joints because it stays wetter, it's colder, and it's the sun doesn't get down to this area as much. A lot of these tiebacks into the building need to be verified, or we need to make new connections off to the side, seal these up so the water is not getting back into the building. A lot of these flats, they have joints where they meet, so these are weakened areas that need to be reinforced from below so that there's not such a spongy effect. Spalling in the cement. This building is, I'm only seeing about 50 to 75% spalling. Here's spalling. It's when the cement is popping because rust is growing behind it and it's pushing the cement out. Rust is growing behind that and pushing the cement out. Rust is growing behind that and pushing the cement out. So a lot of times as you get lower, you start seeing the rust jacking, the ice jacking being more evident down below. Rust is pushing that and spalling that cement connection there. 100% of these treads need to be dealt with. This is the ladder system with that is a sliding ladder. All these are all original hardware. So the day it was built, the hardware is 75 plus years old here. Should have been changed. So the only choice you have to verify this fire escape is to load test it. Otherwise, if you change all the hardware now, you don't have to load test it. All the cement is growing in between the C-channel and the rails and creating bulges. All this must be opened, remove that rust, seal this so that it stops deteriorating your fire escape and gets another 50 to 75 years out of this structure without having to replace it. It's at this area right here down towards the bottom that we have some broken treads. And basically what that is a signal of what's going to happen up above. Right now just one person went up and down and nothing else fell, but these are indicators that additional treads are going to fall up above, and as people go up and down to between floors, servicemen go up and down, people go up and down for whatever reason, people go outside for a smoke and they step on these treads and they give way like that, people will trip, fall down, it's a huge liability. But all these treads, 100% of all the treads need to be rebolted because they're all full of rust, 100%. And down here, 2 of them have already given way, creating a liability and a trip hazard. The rails on the side as commented up above. And now what you have here is a ginger walk crossing these 2. A lot of times this ladder is up here in the up position. This is the hook. And this hook is basically when you put it up, you put it on one of the rungs. When you lift it up, this rung pulls away. So that's usually not that close. And it basically lets the ladder drop down to the ground like a guillotine. But right now she's been in the down position since I got here. 100% of all original hardware is still here. And the platform is, again, you got rust in the joints. So every riveted joint connection must be opened, cleaned, primed, and then sealed with 50-year silicone. So again, because the fire escape does have problems, you're going to need a permit. It's going to need engineer oversight as part of the control of this, and this is a commercial building, so all these things have to be discussed and what the procedure is for a commercial repair of a fire escape with engineer oversight for this area. Any questions? Fire escape engineers, inspector summary video. Inspector Meneses here, 866-649-0333. 866-649-0333, and these are the emergency areas right now, and an emergency letter will be sent.